Alright, this is the 2012 Methods Exam 2. We're going to go through the 22 multi-choice questions. I've got the Casio ClassPad 2 here, the latest version. Hopefully you can follow along with what I do on that. I don't actually need to use it too much in this exam, I found, so we'll see how we go. I'm going to try to make this video a bit shorter than the last one, so let's get straight into it. Question 1. Really easy. You would not want to be one of the 9% that got this wrong. The function with this rule, what's the period? So the rule for the period is 2 pi on n, so 2 pi on 5, so that's 10. Question 2, for the function with rule f of x equals x cubed minus 4x, what's the average rate of change with respect to x on the interval 1 to 3? So average rate of change, that's just like finding gradients, so we just want y2 minus y1 over x2 minus x1. So if we sub in 3 into the function, sub 1 into the function, divide it by 3 minus 1, which is 2. So we'll do a bit of calculator work here. I actually want to show you a new button, which I haven't used before in one of these videos. And that is this button here. Okay, it's the given that button. So it helps you sub things in. It's not super useful for this question, but it's an appropriate time to show you. So that's what happens. We can get my f of 3 and f of 1. So when we sub 3 into the function, we get 15. So we want to do 15 minus negative 3, which of course is 18. 18 divided by 2 is 9. So the answer is E. Shouldn't have to do 18 divided by 2 on the calculator, by the way, but there you go. This one, the range of this function, x squared minus 2x minus 8. We want the range of the function, so maybe just sketch it on the calculator if you're not sure. The issue is, I think where most people go wrong is they just assume I've got to sub negative 2 in and sub 3 in, and that'll give you the range. But that's not going to work. Well, it might not work because we don't know if there's a turning point in there. So you could work out where the turning point is, and you could do it all by hand, and I'm sure you get the right answer, but probably just as easy to sketch it. Looks like I prepared this one earlier. And let's have a look at the interval. So negative 2 is an x-intercept. The upper end of the domain is 3. So my range, my top end of the range is going to be 0. So I've already narrowed it down to C or D. And the bottom end of the range is going to be that minimum. Minimum is at, and it's flashing here because I've actually got 2 graphs on the screen. So I just push EXE, and that's negative 9. So it was D. I'll just clear I'll clear these so they don't cause us problems later. Alright, question 4. We had a really similar question to this on the 2011 exam. But this time I thought I'd actually show you how it works with a function. So g of e to the kx is a composite function. So what do you get if you differentiate it? So let's just pretend that g of x is sine of x. So that would give you sine of e to the kx. If you differentiate that, you get the derivative of e to the kx out the front, which is ke to the kx, and then you of course get cos e to the kx, cos being the derivative of sine. So cos of e to the kx would be g dash e to the kx, and you get a. Hopefully that makes a bit of sense between the 2011 one and this one. Hopefully you will be able to do another one. Anyway, question 5. So now we've got a weird function here, log e of x minus 2 all squared. Now, I think if you had no idea what that looks like, and I wouldn't blame you, I would just sketch it. So ln, we'll use ln because that is the same as log with a base of e. And we'll type in x minus 2 all squared, and we'll drag it onto an axis. Here we go. So we get that weird looking graph here. Now where most people go wrong is the calculator doesn't like to graph asymptotes. So it doesn't put in a dotted line, but there's clearly an asymptote here. So the graph does not stop there, even though it seems like it does. It keeps on going, but it just can't draw it. But that shouldn't affect our answer anyway. You should hopefully therefore be able to see that the domain would have to be all real numbers except for 2, if that is indeed an asymptote. And the range, I think if one of the options here was negative 6 to infinity, I think you'd have a lot of people putting that, and that's possibly why 23% put this. but the range is actually R. This keeps going down here, and we'll keep going to positive infinity. Now, if you weren't sure, if you're worried that it stops at -6, we could always do a YCal and just type in a number that's close to close to 2, so maybe, I don't know, 1.9. And what you find, is you get, we're going to need to go closer than that. Let's try 9999. And we get way down here, we get -18. So the graph is still going. Okay. Anyway, who cares? It's B. Question 6, we clearly have a tan graph here. We've got to figure out what the rule for this function could be. I'd straight away look at the period. The period is pi on 2, so it either has to be C or D. And then if you know what a normal tan graph looks like, which this part here would go through the origin, so it looks like it's been moved to the right by pi on 4, which would give you C. Now, if you weren't sure whether it was C or D, you could always just graph the two of them and figure it out like that. Up to you, but looks like 72% got it right. Moving on, question 7, the temperature inside a building T hours after midnight is given by this function here. So what's the average temperature between 2 AM and 2 PM? So it's asking you for the average temperature. So what we're going to need to do here is find the average value of the function. What we're not going to do is find the average rate of change, which was a false start here by me. I don't know, I wasn't thinking. And if you did that, thankfully you didn't get one of these 5 options. So if you were stupid like me, you would have realized that it was average value of a function it's looking for. So 1 on 14 minus 2. Don't do 14 minus 2 in your calculator, just put 12. Multiplied by that integral, which you should know how to do. So 14 and 2 of 22 minus cos of, it's a bit of an annoying one to type in, pi on 12 times, I'd use x instead of t so I don't have to go into the variable menu, and that will give me an incorrect number of arguments because I forgot to close the second bracket. There we go, 22, so that's D. So don't panic if you get something weird coming up like incorrect number of arguments. Just have another look at what you've done. It's probably something silly like a missed bracket. Alright, now I found this exam, there are quite a few questions that are a bit hard to get your head around, and I think this is the first one. So we've got this real messy looking question here. The function, if we take it apart bit by bit though, it's actually not that hard. So what we've got is some cubic ax cubed plus bx squared plus cx. The first hint is where a is a negative number. So if a is a negative number, that means that my cubic is going to be upside down. It's going to start in the second quadrant and finish in the fourth quadrant. Ignore that line there, that was a mistake. So for the numbers p is less than m is less than 0 is less than n is less than q, f of p and f of q equal to 0. So p and q are x-intercepts, and m and n are stationary points because the derivative at m and the derivative at n is 0. So if you try to graph that, and I'll just highlight this bit, there's p and there's q. Those are my two x-intercepts, and m and n are stationary points. So the graph, the only way for a cubic to pass through those points is if it looks like this. Okay, so then if we want to know, well, when's the gradient of this graph negative? Well, the gradient's negative from negative infinity to m, and then from n to positive infinity. So the answer was A. Okay, so again, if you break it down bit by bit and draw up a diagram, it's actually not too difficult. Alright, question 9, another pretty tricky one I thought. The normal to the graph of y equals the square root of b minus x squared has a gradient of 3 when x equals 1. So what's the value of b? So what I would do here is I'm just going to see what's going on with this normal. So I'm going to do a calculation and work out, well, what is the normal of the graph b minus x squared? I might actually use a b here. B minus x squared when x is equal to 1. Oops, wrong x. So, okay, so the gradient, sorry, not the gradient, the equation of the normal is the square root of b minus 1x. So it's actually, it's just a straight, it's obviously a straight line, the normal, but the equation is just root b minus 1x. So the gradient of the normal, because this is just like y equals mx plus c, the gradient of the normal is the square root of b minus 1. So if we're told that the gradient of the normal is 3, then that means that the square root of b minus 1 is equal to 3. And if we solve that, take the square root over, you get 9 and add 1, b was 10. Okay. Moving on to question 10, almost halfway through. Simple question, average value of a function. If you know the formula for the average value of a function, you should have been all good. The trip here was that we're actually trying to solve for the upper terminal a. So we're going to need to use the average value of a function formula and set it equal to 0.4 and solve for a. And the calculator will do that for us. So action advanced solve. We're going to solve the equation 1 on a multiplied by the integral from 0 to a. Hopefully you know that sine squared x is the same thing as sine x all squared. dx, and we want to set that equal to, make sure you get out of that x, the dx, to push across, equals 0.4, and we want to solve that whole thing for a. And I think we'll find we get something weird come up here. So if we push OK, so because we're dealing with a sine graph, there's going to be multiple solutions. So it's just giving us 2, negative 1.297 and positive 1.298. So obviously it has to be C. Now we could actually, at the end of this, and this might be useful for other questions, is put a given that and then put a set of bounds on it. So we could say, well, that A has to be between 0 and 2 pi, because that's the domain that we're working with. Again, it says that, but then it only comes up with the one that's inside the domain. So 1.298, okay? But I wouldn't have bothered with that for this particular question. Okay, so question 11, weights of bags of flour normally distributed with a mean of 252 and standard deviation of 12. 40% of the bags weigh more than X. What does X have to be? So this is an inverse normal question. Go to your inverse normal, your tail setting will be right, and the probability will be 0.4. The mean, the standard deviation is 12, and the mean is 252, and we get 255.0, which is E. Okay, moving on, question 12. We've got a badminton player who, if they win a game, probability they win the next one's 0.7, and if she loses, the probability she loses again is 0.6. So if she just won a game, what's the probability that she'll win exactly one of her next two? Now, I would not bother with Markov chains here. I'd just draw up a quick tree diagram, or you probably don't even need the tree diagram if you just sort of think about it. If she wins, the probability that she wins the next one is 0.7, and then, so if we think we want to win one of the next two, so either win-lose or lose-win, so the probability of a win and then a loss would be 0.7 times 0.3, and loss then a win is 0.3 times 0.4, which gives you 0.21, and 0.12, which is 0.33. Okay, don't try not to over-rely on your calculator. There's no reason why you couldn't do that without it. Okay, question 13, over halfway now. So we have two events of a sample space S. The probability of A intersection B is 2/5 and A intersect with not B is 3/7. So if you draw up your Venn diagram, you get that. Now we want to know the probability of B prime given A. So that's going to be the probability of B prime and A divided by the probability of A using the conditional probability formula. Now this probability here is the same as this probability here, which is 3/7, and the probability of A would be 3/7 plus 2/5. So I need to do 3/7 divided by 3/7 plus 2/5. So I wouldn't worry about trying to do all that by hand, just chuck it in the calculator. 15 on 29. Alright, question 14. This time we are finding the approximation for an area bounded by F, the y-axis, and the line y equals 4, which is a strange sort of area. So it's not too hard to work this out though. If we want an approximation to the area, we just need the area of each of these four rectangles. So to get the height, the length of each rectangle, we'd need to know the x coordinate at each of these points. And to do that, you could just sub 4 in for y here. So 4 is equal to the square root of x, so therefore x is 16. And that would make that 9, that 4, and that 1. So the four rectangles, the height of each rectangle is 1, so you just need to do 1 plus 4 plus 9 plus 16, which is 30. Okay, question 15, the classic pick a graph question. So it's the reverse of 2011. In 2011 you had to find the graph of the derivative. This time we're given the graph of the derivative and we want to, what could the graph of f of x have been? So the answer was B. Most people got it right. Hopefully you recognize, well, if f dash of x is a quadratic, then f of x would have to be a cubic, so it's either going to be C or D. If you were to quickly sketch 3x squared minus 4, it's got two x-intercepts obviously, so that means that the cubic would have to have two turning points, so it had to be B. Okay, so 16 is another one, a little bit tricky to get your head around, but it's actually very similar to a question from 2011. I forget which one, but I'm sure you'll recognize it once we do it. So the graph of a cubic has a local max at A -3 and a local min at B -8. So I've drawn that here. So there's a local maximum with, I've just drawn in the y coordinate there. This is A -3 and this is B -8. It doesn't actually matter what A or B are here. So what are the values of C such that the equation f of x plus C equals 0 has exactly one solution? So it's a fancy way of asking you, this cubic here, what can I add to it? So how can I move it up or down so that the cubic only has one x-intercept? And as it stands, the cubic already has one x-intercept. So what we want is if we add on a number, we want to add on something so that it still has only one x-intercept. So what would happen here, if we started moving the graph up, what would happen once we moved it up to past 3? So if we moved it up 3, then this little maximum here would be touching the x-intercepts. And if we move it up any further, then I've got 3 intercepts. So I don't want to move it up more than 3 unless I move it up so far that this minimum also goes up above the x-axis. So what I want C to be is I want it to be less than 3, or I'd want it to be more than 8. And so long as I have that, I'll only have one solution. So that's where this answer of D came from. C is less than 3 or C is greater than 8. Okay, question 17. a system of simultaneous linear equations. It's a pretty quick way to go about this one, I thought. So here's my linear equations. Now if I just write them out normally, I'd have mx plus 3y equals 1 and x plus m plus 2y equals m. So we want to know, when does the system of equations have no solution? Now whenever you've done questions like this, you find the determinant, and what usually happens is the determinant is 0 when m is two different things, and for one of them there'll be no solution and one there'll be an infinite amount of solutions, almost always. So that really rules out D, and it really rules out E and C as well. So let's just have a look at what happens when m is equal to 1. If m is equal to 1, I get 1x, or just x plus 3y equals 1, and I get x plus 3y equals 1. So if m equals 1, there's an infinite amount of solutions. So that rules out A, and even though we already ruled them out, it also rules out C and it rules out E. So it has to be B. I'm not even going to bother subbing in -3. I'm just going to assume that -3 gives you the same gradient. Okay, so moving on. Question 18 was, I think, a very difficult question. You see the most common answer, 32%, is actually wrong, which is very rare. So what have we got going on here? We've got the tangent to the graph of y equals log e of x at the point a log of a crosses the x-axis at the point b0, where b is less than 0. Which of the following is false? Now there is kind of a logical way to go about it, and I was going to do it that way, but I think I might try and do it the cheat way. And if you want to look at the kind of the proper way, go have a look at the examiner's report. But I'm going to kind of attack this from the perspective of someone who had no idea what they were doing. So, and what we're going to do is we're going to start by having a look at the graph. So, log of x, should already know what log of x looks like, but if we graph it, this is what we get here, and I'll make it nice and big. So the tangent to the graph at the point a log of a, so if we draw a tangent at any point on the graph, we want to draw it so that the tangent, it crosses the x-axis at the point b0 where b is less than 0. So in other words, we want to draw a tangent so that the tangent has an x-intercept that's negative. So you can see if you draw a tangent way up here, there's going to be a negative x-intercept. But if you draw a tangent, say right here, then the x-intercepts of the tangent is going to be positive. So where do we draw the line? Where can I draw it? Where do I draw my tangent so that the x-intercept of the tangent is negative? If we have a look at the options, if you're kind of clever looking through these options, you should be able to see that two of them contradict each other. The two that contradict each other are A and C. So one of these two has to be false because A, it's suggested that A is has to be between 1 and E, or A has to be greater than E. So both of those things can't really be true. So that's what we're going to do. We're going to narrow it down to which one it has to be. And I kind of already have, because if you remember before, I was saying if I draw a tangent way over here, then the x-intercept of the tangent is going to be negative. And that would certainly be when A is bigger than E. So that one's true. So the answer is actually A. And if I was kind of thinking about it in that way, I wouldn't really have to do anything more. So I'm going to move on. Again, if you want to see the proper way to work it out, go have a look at the examiner's report. Okay, question 19, if you know your unit circle, you probably got this one. So we want to know a function that has the property that f of pi minus theta is equal to negative f of theta, and f of pi minus theta is also equal to negative f of negative theta. So really, this has to be equal to this, which is equal to this. And the only function that works for is it's either going to be a, b, or c. This x on 2 or 2x shouldn't really affect things, so it either has to be sine, cos, or tan. So if you just draw up a unit circle, there's theta, there's pi minus theta, and there's negative theta. So hopefully you should know that cos of pi minus theta is the negative of cos theta, and cos of negative cos of negative theta is going to be the same as cos of pi minus theta as well. So it was B. All right. Worst case, you could just sub something in and see if it works. Okay, moving on. Question 20. Here's another example. 27%. Most popular answer was wrong. But these five are pretty well spread out. I think people had no idea with this one. We've got a discrete random variable with the function, with the rule that the probability that x is equal to k is equal to 1 minus p to the power of k times p. So what's the probability that x is greater than 1? That hasn't come out that well, but it's greater than, not greater than or equal to. So the probability that x is greater than 1 is the same thing as 1 minus the probability that x is 0 or x is 1. So all I had to do was sub 0 in for k and sub 1 in for k and sort of simplify this expression here. So 1 minus p to the power of 0 is p. I really just could have put this in the calculator, but if you simplify it, you get 1 minus 2p plus p squared. That wasn't one of the options, but it's certainly not any of these. So I'm pretty sure it's E, and if I just expand that to check, I get that anyway. So E was correct. Okay, second last question was a related rates question. A pretty straightforward one. If you know your related rates, you should have been fine. So we've got a volume of water in container. The volume is given by 1/3 pi h cubed, and the water's draining at 300 centimeters cubed per minute. So dV dt, which is the rate that the volume is draining, is 300. dV dH is the derivative of this, and dH dt is what we're trying to find, the rate of decrease of h. So you set up your related rate formula here, sub in 300. If you differentiate 1/3 pi h cubed, you get pi h squared. Leave dH dt as it is. If we divide that to the left-hand side, we get 300 over pi h squared. We want to know when h is 5. 5 squared is 25. So 300 over 25 pi, it simplifies to 12 over pi. Okay, last question. Again, this was a pretty tricky one to get your head around, I thought. So let's see if we can do it step by step. The graph of a differentiable function f has a local max at AB, where a is less than 0 and b is greater than 0, and a local min at CD, where c is bigger than 0 and d is less than 0, which would look like that. Okay, it might not be a cubic, but let's assume it is. If a is less than 0 and b is greater than 0, I'm in this quadrant here, and so on. CD would have to be in this quadrant here. So if that's a max, that's a min. Let's assume that the graph looks like that. So we want to know, what does the graph of negative the modulus of f of x minus 2 looks like? So what I've done, I've ignored the negative and I've graphed this over here. So I've moved the whole thing over by 2 and I've found the modulus of that function. So if you move the whole thing over by 2, AB becomes A plus 2B, CD becomes C plus 2D. And now if we find the modulus of that function, everything that's under the x-axis gets flipped above the x-axis. So that's how we get this shape here. And this point here stays A plus 2B, and this point here would become C plus 2 negative D, because my D coordinate here has gone up here. So then all you do then, if we want to graph negative negative modulus of f of x minus 2, turn the whole thing upside down and you get this. So A plus 2B becomes A plus 2 negative B, and C plus 2 negative D becomes C plus 2 positive D. So I end up with two minimums. So a local minimum at A plus 2 negative B and C plus 2 positive D. You'll see it was easy to muck this one up, but certainly if you knew that there were 2 minimums, at least you had a 50-50 chance. And that's it for this exam, so thanks for listening, and we'll be back with the 2013 in a couple of days.